Assalamu alaikum, good day. I'm Farah. So before I started my research journey, I always thought that people who studied bones and tissues were only for medical doctors, but I guess I thought wrong. My work here today is on the topic of mechanical behavior of cancellous bone, compression, and three-point bending test. Cancellous bone, or also referred to as trabecular bone, or spongy bone, is typically found at the ends of long bones and within the vertebral bodies. Here in the figure is a section of the femur bone, whereas the dashed area here shows the location of the cancellous bone. As you can see, the small holes here is the structure of the cancellous bone. In a more microscopic view, as shown in the figure here, the region of the cancellous bone is filled with porous structure, or also known to be small holes. Cancellous bone are mainly porous structure, which are an anisotropic structure, and it functions to support 75% of the body weight, whereby it functions to optimize the load transmission within the body according to its architecture, cancellous bone properties, and also bone volume fraction. The study aims to present the mechanical properties of cancellous bone between uniaxial compressive load and three-point bending load. It is hypothesized that different loads subjected onto the cancellous bone specimen results in different mechanical behaviors. In the study, bovine bones of the femur and the tibia are experimentally used to conduct the compression and three-point bending tests. For compression tests, the femur of bovines, whereas the femoral heads are cut and shaped into cylindrical specimens with a diameter of 10 mm and a length of 25 mm. Here shows the figure of the cancellous bone specimens under compression tests. Figure A is where the specimen is secured in a jig device where these end caps are used to secure the specimens to avoid the specimen from slipping during the test. And figure B shows the setup of specimen mounted onto this universal testing machine during the compression test. For the three-point bending test, cancellous bone specimens from the tibia of bovines were extracted and cut into sizes of 30 mm times 20 times 10 mm. Before all the specimens were used to test for the compression and three-point bending tests, the remaining bone marrows and fats were removed using air jet and also immersed in ultrasonic bath to allow the bone marrow to be removed easily. This here is a figure of the cancellous bone specimen under three-point bending test. The left image is the specimen mounted on the three-point bending jig before the test is conducted, and the right image is after the test is conducted. As you can see, there is a small crack on the bottom of the specimen, due to the bending test. From the test conducted, the results between both compression and 3-point bending tests shows different results. In figure A, the compression test showed that cancellous bone specimen was to fail between 4 to 5 megapascal, whereas in the 3-point bending test, cancellous bones specimen were found to fail within 16 to 18 megapascal. Apart from that, correlations between morphological studies of this bone specimen were also analyzed with the mechanical behavior of the cancellous bone specimen under both compression and 3-point bending test. In figure A, the correlations between ultimate stress of cancellous bone under compression test and bone volume fraction showed a correlation of 19.4%, whereas the flexural strength of cancellous bone under 3-point bending test and bone volume fraction BVTV showed a correlation of 8.1%. Between the correlation of modulus and bone volume fraction under compression test, it showed that cancellous bone had a correlation. The mechanical behavior of cancellous bone had a correlation with bone volume fraction with 37.0%, whereas cancellous bone under 3-point bending, the flexural modulus, the correlations between flexural modulus and bone volume fraction showed 5.2% correlation. The ultimate stress of cancellous bone specimen under compression test when correlated with porosity showed 19.3%, whereas the flexural strength of cancellous bone specimen mechanical properties under 3-point bending test when correlated with porosity showed 8.1%. And also, the modulus properties of cancellous bone specimen under compression test when correlated with porosity showed 20.1%, whereas the flexural modulus of cancellous bone specimen under 3-point bending test when correlated with porosity showed 5.0%. The tables here showed the results between porosity of the specimen, the cancellous bone specimen used in compression and also in 3-point bending tests, and also the bone volume fraction between the two types of specimens, and the results of ultimate stress, Young modulus, flexural strength, and flexural modulus. From here, it is found that there are different in porosity and bone volume fraction between the two types of bone specimens, compression and 3-point bending, and also different ranges of mean according to different mechanical properties when the cancellous bone specimen is subjected to compression and 3-point bending tests. From the work conducted, there are several factors that are highlighted. It was found that factors influencing mechanical behavior of cancellous bone consists of bone volume fraction, or BVTV, according to anatomic sites, the load subjected onto cancellous bone, whereas in this study, compression and 3-point bending loads are used, the specimen size of bone, anatomic site, and also the porosity of cancellous bone specimen. The hypothesis is accepted whereby different loads subjected onto the cancellous bone specimen resulted in different mechanical behaviors. And as a conclusion, mechanical behavior of cancellous bone structure was found to be much higher under 3-point bending load compared to under compression load. Although the correlations between mechanical behavior of cancellous bone specimen under 3-point bending tests with morphological properties such as porosity and bone volume fraction showed lower results compared to compression tests. That is all from my presentation. Thank you.